All right, welcome. We are looking at number 35, 36, 37, 38, 39 of your final review packet. We're going to go ahead and get started. We are reviewing for our Try 2 final. It says state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem you used. If you watched my last video, you know that your options for similarity, postulates or theorems, are angle-angle similarity, side angle side similarity, or side 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 similarity. Now if I look at this one right off the bat, I notice we have a 47-degree angle and another 47-degree angle. So that tells me you're probably going to use angle angle or side angle side. So side 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 is out. The next thing I notice is that there is not a side length written on this. There are no numbers on the outside. I don't know how big any of my sides are, so really side angle side is also going to be out. Now that tells me I'm left with angle-angle similarity, but I guess the question is why? What I notice is that we have vertical angles here, or kissing V's, or bow tie angles, or whatever your teacher calls them, and those two angles are congruent. So we do have two pairs of congruent angles, which means we can use angle-angle similarity. We need to write a similarity statement. So for my first one, let's do triangle HGM, and then we're going to say is similar to, and then my second one we need triangle, and then whatever's in the same spot as H. Well, H is 47 and so is K, so K is going to go first. And then whatever's in the same spot as G, in our case that's going to be J. And then the last one will be M. And that is your similarity statement. Again, they're similar by angle-angle similarity. 36 says we're doing the same thing. State whether triangles are similar. If so, write a similarity statement and the postulate or theorem you use. Again, we're looking for angle-angle similarity, side angle side similarity, or side 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 similarity. Again, right off the bat, I notice I have two sides, but I don't have a third, so I'm going to throw out side side side. I also notice that I have, that circle is weird. I also noticed that I have one angle, but I don't have two, so angle-angle is also going to be out because I can't infer any of those things. Right now I know I have two pairs of congruent angles, 29 and 29. So my next step is to check and see if my sides are proportional. What that means is I'm going to take my longest side here, 64, and we're going to divide it by the longest side in the other one, 32. And we want that to equal my other side, 16, divided by my other side, 8. Well, if I do 64 divided by 32, I get 2. 16 divided by 8, I also get 2. So that means they're going to be similar by side angle side similarity. And then we need to write a similarity statement, I believe. Yeah. So we're going to say triangle, let's see, QRS is similar to, now Q is at the top, it's on the edge of my blue line, so we're going to do V. And then R is in the same spot as T, and then S and U are in the same spot. So again, it's congruent, or excuse me, similar by side angle side similarity, and there's our similarity statement. 37, state whether the triangles are similar. If so, write a similarity statement. All right, for this one, we are looking at our large triangle here, and then this little small one. Notice they both share this angle right here. Again, our options are going to be angle-angle similarity, side angle side, or side side side. Right off the bat, I notice we only have like side lengths on this side, and on this one, there's nothing down here or right here. So it can't be side side side. I am going to erase those little circles because they're in my way. But I do have enough information to use side angle side. Notice I only have one angle, that green one we drew in, so that means that angle is also thrown out. So we're going to check using side angle side. Now the first thing I'm going to do is look at this entire red length, which is 33 plus 11 divided by, and then we want to do this little blue one, 33. And we want to see if that's equal to my entire red length again, 21 plus 7 divided by the little blue one, which is just 21. If I do 33 plus 11, I get 44 divided by 33. And we want to see if that's equal to 28 divided by 21. Now, if I put that in my calculator, 44 divided by 33 gets me 1.33, and my 3 is gone forever. 28 divided by 21 gives me 1.33, and my 3's go on forever. So these are going to be similar by side angle side similarity. Oh, sorry, those were too many A's. And then we have to write our similarity statement. So we're going to do triangle. Let's name our blue one first. OJK is similar to triangle. Again, O is in the same spot as O. M is in the same spot as J. And N is in the same spot as K. So there's our answer there. And 38 says, which group contains triangles that are all similar? Again, our options for similarity are angle-angle similarity, side-angle-side similarity, or, what am I missing? Side-side-side similarity. Now my first one, notice we're talking about this triangle, and the large one. Notice that they all have right angles right off the bat, and all three of them use this little angle here. So these ones are similar by angle-angle similarity. So A is an option. Let's look at the rest of them just to make sure. Notice right off the bat this one has this one big triangle, and then it has a bunch of other little ones. In fact, I think it has 4 other little ones. Notice they all share that top angle, but really nothing else. And I don't have any side lengths, so I can't check side lengths. So C is out. My next one, notice we have a 53 and a 45 and a 53 and a 45. Again, those angles need to be the same, so this one's out. Again, this one and this one would have to match. This one and this one would have to match. And my last one, we have a 32-degree angle here. We have a 32-degree angle on the other side because of vertical angles. But notice that one of my sides touches my angle and the other one doesn't. And same thing for the other one. And our only option where we can use sides and angles is side, angle, side. And the important thing about side, angle, side is that angle is between the two sides. Notice it's between your two S's. So if we wanted to use side, angle, side, we would need this side. We would also need that one because it would touch our red angle. On the other triangle, we would need the matching sides, so this one and this one, because again, they both touch that red angle. So your option A is going to be your correct option. 39 says, use the information in the diagram to determine the height of the tree to the nearest foot. I think we're to assume that our triangles are similar because they are. You kind of have some options here. I think I've seen people do it a couple of ways. The first thing I notice is that technically speaking, we have a little right angle there. So if you wanted to use the Pythagorean theorem, a squared plus b squared equals c squared, you are more than welcome to. Honestly, to be honest with you, I think this would be the easiest way to solve this problem. And that is maybe how I would do it. In fact, that's how I'm going to do it. So if I make my triangle a little bigger so I can see what's going on, we have 120, we have my little right angle, and we have 144. Again, we are trying to find this missing side length here. So I'm going to call this one A. I'm going to call this one B because those are my legs. Again, across from my right angle, we have our hypotenuse 144, which is going to be C. So if we plug that in, we have 120 squared plus B squared equals 144 squared. When we do that, if I do 120 squared, I get 14,400 plus B squared equals 144 squared, which is 20,736. I'm going to move this 1,400 to the other side by subtracting it. It's not 1,400, it's 14,000. Anyways, that big number, we're going to subtract it. And we get B squared equals 6,336. Now my last step is to take the square root of both of these things. When we do that, we get second square root, 6,336. We get B equals 79.5. They want us to round to the nearest foot, so I'm going to move this over here. So we're actually going to call that 80. feet. And that is how tall the tree is. Now I think, and by I think I mean I know, notice they tell us that this part and this part are the same. So we could say this is 144. They also told me that this part and this part are the same, so we could say this is 120. Now technically we're looking for x here, and you could set up a proportions problem where you do these two sides over each other. So maybe, sorry, I'm gonna smoosh a little bit so I can tell you. So do the two blue sides together. You could do 160 over x. Gotta switch back to my pen. Equals, and then you could do your entire green side, 144 plus 144, which is 288, divided by 144. And when you do that, you should be able to cross multiply and solve for x. Now what I notice here is that right now we have 288 and 144. Well, half of 288 is 144. So half of 180 or 160 would be 80, which is what we found using the Pythagorean theorem. If you like the Pythagorean theorem, use that one. If you like fractions, do that. It's totally up to you. Either way will work. Whatever floats your boat. All right. Thank you for watching. Good luck on your final.